Alright students, I'm going to narrate and bring you guys through the question 1 of your practical papers. Pardon for the not so ideal quality of the recording, but I think it serves its purposes. Okay, so first of all, I will not toggle between the question paper and the video, so I'm just going to voice over. So you will need to have your question paper with you. If you take a look at the first page, or rather the second page, for the qualitative analysis of FA1, you'll notice that FA1 is a solution that contains 2 cations and 1 anion. You need to have the unknown in mind before you start doing, and then you need to read through the instructions. So I'm not going to read through the instructions, but you might need to focus on things such as for each stage of the test, you're supposed to record any color change, formation of PPT, and then the solubility of the PPT in excess of the reagents being added. And then you're probably needed to test for the gas as well, because I think the next part they said that if the gases are released, you need to identify them. Okay, and then they also mentioned that you're not supposed to perform any additional test, so therefore you can keep it to what is given in your question paper. Yeah, so the reason why we are doing this is really because this QA is a bit of the unusual side, a little bit. There's some novelty element involved, so we thought that it's clearer if we bring you through. Okay, so the first test is given to you, the results. You were told that you observed white PPT after effervescence ceased. Yeah, so based on what you have learned, after sodium carbonate is added and if you observe effervescence, that means that the solution is mildly acidic. Yeah, the mild acidity is probably due to 1 or 2 of the cations hydrolyzing in the aqueous medium partially to give some H+. Yeah, so with that in mind, you probably will be able to come up with some possibilities, taking into consideration the color of FA1. Okay, so right now let me play the video. The video has no sound, so I'll be the one voicing over. Yeah, so this is a washed test tubes, boiling tube. Okay, so you have FA1 here. You notice that FA1 is colorless. Okay, so you're supposed to add in 1 cm depth of FA1. Okay, you don't need to measure using a ruler. Okay, so you just roughly add in about 1 cm. Okay, and then after that, you're supposed to use a dropping pipette to introduce sodium hydroxide, okay, into the measuring cylinder. Okay, so I think the instructions was very clear, about 6 cubic centimeters. Yeah, then after that, you're supposed to transfer them in 1 cubic centimeters addition to the boiling tube. Please take note of the color. Okay, so the color of FA1 is colorless. Okay, so as you have seen here, and then after it's introduced, you'll notice that you see a little bit of white PPT observed, and immediately the white PPT sort of gets oxidized. Okay, so if I just pause here for a little while, let me see where to pause. You'll notice that there is sort of like a mixture of color, okay, of white and brown, but you can't really tell them apart because you don't know whether the white one comes first or the brown comes first, or they come together. Yeah, so at this stage, probably the only observation you might want to record will be either cream PPT observed or white PPT, some of it turns brown, because at the beginning it's really the white PPT being produced. If I just shift back a little bit, I think you should be able to see it. Okay, so it's too far back. Okay, so slowly add in, and then please check at this point again the addition. Okay, so you see an instantaneous appearance of white, and then after that it quickly turns brown. You can see that the white maybe remains for about slightly less than 5 seconds, and then take note of the wall of the test tubes. Okay, so later on you need to continue observing the wall. Okay, so observation here you might want to write will be white PPT, some of it turns brown, etc. So you need to have that kind of in mind. Okay, then after that we'll continue to add in more sodium hydroxide. Okay, we just add in more and more, and then you notice the side of the test tubes, the wall of the test tubes. It's very clear. It's clearly that there's a brown stain there. Okay, some of you commented that the solution is brown color. Yeah, but take note that in this case our focus here would largely be on the appearance of the PPT, because you can't really tell them apart given such a mixture. Okay, you notice that about two fingers below, the wall of the test tube is actually quite brownish in color. Okay, so you're supposed to add them until your measuring solution is empty, and if most of you can recall, after you empty it, then you really don't get much difference, except that those of you who are a little bit sharper, right, you might notice that the PPT is brown, and then the initial white PPT you observe, right, is not visible anymore. So some of you actually went on to say that it partially dissolved. I think that more or less we can accept that. Yeah, but sometimes you need to ask yourself the question, is it very obvious that you are able to distinguish the partial dissolution? Yeah, is it very obvious given the exam condition? Yeah, so whenever there's a mixture of color, right, you are not really expected to highlight that you have brown and white together unless it's really very clear cut. And then within a mixture of brown and white, is it very obvious that the white PPT actually partially dissolved? Yeah, sometimes it can be quite obvious, especially when the two sorts have slightly different or have very different KSP. Okay, so that's food for thought, something you can think about. Okay, and then moving on to the next part, you're supposed to do filtering. That's on top of page 3. And remember that once you perform filtering, you need to highlight the color of the filtrate and the residue. Okay, so this is just a very quick way of filtering, and then after that, I just put it at the side. Okay, so after a while, we'll come back to visit it and then see what it is like. Okay, yeah. So I think earlier on, I showed you the filtrates. Okay, maybe I should go back a bit. Yeah, so this is the filtrates, colorless in color. Okay, then I'm going to add in dilute sulfuric acid. That is the second row of page 3. Yeah, this is a bit hard to observe. Okay, so if you're in doubt, you might want to take a look at the earlier video being produced. That is on practical 14 or 15, I can't exactly remember. Yeah, that one also show you the complex inside the alkaline solution, and then when we add in dilute sulfuric acid, the PPT reappear, and then in excess it will just dissolve completely. Okay, so take note of this. Okay, so it's colorless now. I add in a little bit of the dilute sulfuric acid, just a little bit. Okay, it's not very clear due to the focus, but I think you can see that the solution is a little bit cloudy, so that's white PPT appearing. Okay, I think it's quite obvious now. And then now I add in a little bit more. Okay, I think if you test it against, I think part of it dissolved already, or most of it dissolved. Yeah, but just now you do see the brief appearance of the white PPT. Yeah, so I think that's good enough. Yeah, so those are the two things you need to record. White PPT reappears, and then dissolve in excess sulfuric acid. Okay, so right now I'm going to do skip to test number 3. Yeah, so this is the aqueous ammonia one. Okay, so I add in FA1, and then if you notice, you get white PPT, and then after a while, you swirl the test tubes, and then you get brown PPT or white PPT turned brown. It's a mixture. Okay, take note of the wall of the container. Yep. Okay, I think at this stage, you guys will probably be looking at your script right now, and you know the identity of the two unknowns, Mn2 plus and aluminium 3 plus. Then you also notice, and I thought it's worth mentioning, that there is a slight difference in the appearance when sodium hydroxide and aqueous ammonia is being added. And most of you, if not all of you, are probably also aware that manganese 2 plus, once you add in the alkaline, right, it will give you the white PPT, and then it rapidly turns brown. Yeah, but the rate of browning, or the rate of turning brown, is different in ammonia and aqueous sodium hydroxide. Yeah, So if you wish to visit the videos again, you may visit it either in this particular video we are talking about it, or you can take a look at one of the QA identification of ion video was made available to all of you. Okay, yeah. Okay, so swirl, then you probably get brown PPT, and then okay, so sorry, it's jumping around, but you get the gist of it. So now we are going back to the earlier part where we're going to do filtering. Okay, so this dilute nitric acid, so just add in. Okay, do take note of one thing: not all the brown PPT will not dissolve completely. This is normal, okay, because the brown PPT is actually a complex mixture. Yeah, so do take note of that. We're not expecting you to dissolve them completely, and it's not mentioned anywhere that it should be dissolved completely. So that is probably something that is very important for you guys, because some of the experiments, even for A levels, you need to learn how to deal with ambiguity. So you are sort of expected to react to new kind of experimental techniques or new kind of experimentation during your A levels. Not everything will be new. Most of it you are familiar with, but maybe a few parts that's a little bit interesting. Okay, now after added, this is what we get. Okay, now a lot of you guys actually claim that this solution is yellow. Some of you claim that is orange. Yeah, but it's actually brown. So you have to be very careful. So I know you can say it's a different shade of brown that might cause you to misinterpret it as yellow or orange. But if you look at it really carefully, it's really more of brown than anything else. Okay? Some of you got colorless. Okay? Nothing wrong with colorless. Colors will simply mean that you are getting the other spectrum, meaning the second sample of your filtrates. So colors is also accepted. Okay? Yeah, but for the first bit, it's actually brown. Okay? Okay, so I'm going to add in oops, let me see what they are going to do, what we are going to do. Okay, so we're going to add something in. Okay, so this is adding H2O2. Okay, you'll notice that it decolorizes. Okay, so you have to record that. Some of you might be wondering, why does it decolorize? Okay, that's something you can think about as well. Okay, if you try adding water to the sample, you see whether it will decolorize. Not sure whether anyone of you tried it out during the actual practical exams. You're not recommended to try new things. I'm just, saying it. Okay, in case you are wondering. And then if you wish to, maybe we can do a demonstration later on. Yeah, okay, so now we are adding hydrogen peroxide. Okay, so I'm going to rewind again, because this is the interesting part that I think a lot of us have not done it before. Okay, so remember that the solution is actually acidic. Okay, and I think as of now you know what is inside. It's Mn3, manganese 3+, acidic medium. Okay, with H2O2. Okay, and you'll notice there's no reaction except for the thing decolorizing. For the brown solution decolorizes, you don't observe any bubbles. Yeah, of course, if you leave it long enough, there might be a little bit of bubbles forming at the bottom, but by and large, no bubbling. Okay, but what happens when you add in H2O2? Sorry, what happens when you add in sodium hydroxide? Okay, take note of it carefully, especially at the top of the liquid. Okay. Okay, one drop in, you notice formation of brown PPT. Okay, and then a little bit of effervescence. Okay, you can see the effervescence over here. Okay. Okay, I'll continue. Okay, you add more. This is very apparent. Brown PPT, a lot of effervescence. Brown PPT, a lot of effervescence. Okay, you swirl and swirl, and then now we concentrate the effervescence. Okay, so this is a bad technique, so please don't do this during exam. You should light up your Bunsen burner. Okay, so this is just to do a shortcut, because we are really doing this towards the end of the practical exams, where most of the things have been kept. So we just use whatever we have to showcase to you. And this is a lighted splint, not a burning splint. Okay. then we just gather, and then we insert. Okay, so we try to keep most of the gases intact. Okay, and then you check. Okay, not very clear. Okay, not very clear, but it does light up a bit more. Okay, so I'm going to add in more of the sodium hydroxide for more oxygen to be released. Concentrate them. Okay, we test it again. Okay, so now it's obvious. Now, when the splints burst into flame, you might mistook it for an explosion. So it's different. So this is re-ignition, okay, due to oxygen. Yeah, and then it bursts into flame. So this is not explosion. Yeah, the difference between this and testing for H2 is that for H2 you are using a burning splint. Yeah, so the burning splint, the fire, all right, it creates the activation barrier. I mean, it creates the energy, high energy environment, right? When you insert it into the test tube, okay, the hydrogen gas release, right, at the surface over there, right, because of the high barrier being overcome, okay, by the presence of the burning splint, right, it leads to reaction between H2 and oxygen. So you notice an explosion because the explosion actually forms steam. Yeah, so that is called explosion. It's different. So there's a difference in the way you draft your answers for the hydrogen gas test versus oxygen. Okay, for hydrogen gas, it is burning splint extinguishes with a pop sound. So that's a small explosion. But for the case of oxygen, the lighted splint bursts into flame. Okay, yeah. So that because quite a lot of scripts miswrote the answers as the test for hydrogen, which seems to be quite similar, but actually they are totally different in nature. Okay, and actually that's about it, because if I move on, there isn't any more interesting things I can say. Okay, it's just continuous testing or showcasing the oxygen gas, the identity of the oxygen gas. So it's not really very interesting. Okay, if you want, I can show you one more. So this one really bursts into flame. Okay, now at the end of the day, right, what is the color of the solution? Okay, so I just rewind a little bit more. Okay, rewind a bit more. Yeah, okay, you notice that it gives you very dark brown solution. The PPT remains, okay, and of course if you leave it long enough, the effervescence ceased. Okay, there's no more effervescence. Okay, yeah, the remaining amount of oxygen of course will give you that light out the flame, light out the burning splint a little bit. I mean, lighted splint a little bit, but not really. Okay, so at the end of the day, what you observed is really the brown PVD remains. Okay, so I'm just going to show you here, over here. I'm just going to stop it. Okay, so the brown PVD remains as well as effervescence ceased. So the reaction has completed.